I first introduce myself. I am Professor Daljit Kaur from Sihangat Academy of Engineering from the Department of Mathematics. And today we start with the second unit of Engineering Mathematics 1, that is the unit of complex numbers. Now what all we are actually going to cover in this unit of complex numbers? The first thing, I'll be giving you an introduction about the importance of complex numbers. So the first is the introduction. Then the second is, we'll be talking about the basic concepts of complex numbers. Next, we'll be talking about the geometrical representation of a complex number. Which is called as the Argand diagram. Next, we'll be talking about the de Moivre's theorem. Then, we'll be applying this de Moivre's theorem to find the roots of equations. Next, we'll be discussing about the hyperbolic functions. And lastly, about the logarithm of a complex number. So these are the topics that we are going to cover one by one. So now I will just start with the introduction to let you know how exactly complex numbers are used in the various fields of engineering. So we start with the first subtopic, that is the introduction. Now, you all are familiar with the set of natural numbers. What are the set of natural numbers? 1, 2, 3, so on. You start with another, you take a little larger set, that is a set of whole numbers. So that is 0, 1, 2, 3, so on. You take a still larger set, that is a set of integers, that is 0, plus minus 1, plus minus 2, so on. Then you come to the set of rationals. How do you define rational numbers? They are numbers of the form sum numerator upon the denominator, where the denominator is not equal to 0. Then next, you have your set of irrationals. What are the irrational numbers? Numbers like root 2, root 3, so on. These all are your irrationals. And now you see, this whole set together, they form your set of real numbers. Okay? Now, you have such a large real number system, and still, what is the need to study complex numbers? So you see, I'll give a very simple equation, x square equal to 1. Now if I ask you what is the solution set of this system, of this equation, you will see that the roots are plus minus 1. And therefore what is the solution set? Your solution set is plus 1 and minus 1. But now if I ask you a question, x square equal to minus 1, what is the solution set for this equation? You will immediately say that the solution set is empty. If you remember, we had come across these type of equations in school. You know what we used to say? A square can never be negative, and therefore you should just ignore these equations. But now we cannot ignore such type of equations. So you see, it is here where complex numbers will play an important role. So what do I do here? I will define an imaginary unit I equal to minus 1. What is this I? It is the imaginary unit. So that if I square both sides, I'll get I square equal to minus 1. And now if I want to know what is the solution set of this equation, I will get x square equal to I square. That means my roots are plus minus I. So now what is my solution set? My solution set is plus I and minus I. So now what do you observe? All those equations which have no solution in the real number system, they have a solution in the complex number system. And you will see this is one of the reasons why we study complex numbers. This is where what is the significance of complex numbers. You will see as we go through the chapter, complex numbers can also be used to find the roots of polynomials. And polynomials are used as theoretical models in various fields of engineering. Now, you will have a question saying that, okay, fine, when we have to solve such equations, we are going to use complex numbers. But we do not use these equations in our daily life. And moreover, you will say, I'm going to be an engineer. Okay, fine, I require mathematics, I will do it. But now the question comes, where do we use these complex numbers in real life? Or by being an engineer, how are you going to relate this mathematics to your engineering subjects? So you see, in real life, engineers use complex numbers to measure the AC voltage. Because when you're going to measure the AC voltage, the parameters which are there, you are going to express them in complex number form. Further, I can say engineers use complex numbers to analyze the stresses in structures such as bridges and buildings. Further, I can say engineers use complex numbers to design and test. Engineers who design speakers, they also use complex numbers. Then engineers who design and test the strength of the bridges also use complex numbers. Then scientists who do experiments scientists who do experiments on ways to make energy using fuel cells, batteries, solar cells, they also use complex numbers. And my basic aim of telling you these applications is that when you're going to study actually these engineering subjects, you're able to correlate mathematics with those engineering subjects. So with this introduction, the next part what we'll go is, we will study what are the basic concepts of complex numbers. Like, what do we exactly mean by a complex number? What are the different operations, like how do we add to complex numbers? How do we subtract to complex numbers? How do we multiply and divide complex numbers? So, we come to the definition of a complex number.